Hello everyone, welcome to this topics video where I take a problem that looks like this, seems kind of busy to me, and given that angle 4 is less than, the measure of angle 4 is less than the measure of angle 8, how do these angles 3 and 7 compare? And then how do the sums of angles 1 and angle 2 compare to the sums of angle 5 and 6? Okay, so the student would have to select the correct inequality sign to answer this question properly. So I thought this would be a good time to kind of just talk about and show how easy it is really to set up a problem like this so that students can get a good understanding of, the angle relationships here instead of just answering, a static question like this one. So I'm just going to open up GeoGebra and I'm going to put a line down here. We need 4 points on the line and then 2 points off the line to make our triangles. And then we'll measure all 4 of these angles and all 4 of these angles and then make sure that this angle 4 is less than this angle 8. That's the only criteria that we have to meet. And so as long as we have that, then we'll compare our angles. Okay, so I'm going to open up GeoGebra. I'm going to grab my line tool and I'm just going to put a couple points down to make a line. And then I'm going to put a couple more points on so that now it looks like our picture, and I'm going to put a couple points up here to make our triangles. So now I'm going to grab in the line toolbox, I'm going to grab the segment tool and make these triangles here. Okay, so now let's measure the 3 interior angles and then these exterior angles over here. So when you use the angle tool, make sure that, I like to use the 3-point way of measuring an angle. So you always have to measure, if I want to measure, say, this angle A right here, you have to go in a clockwise direction, and you start with a point that's on the side of the angle. So like C is on the side of this angle A, so I'm going to start with C, and then I'm going to click on the vertex, which is always second, and then notice how GeoGebra is waiting for me to put the 3rd point down, which will be this point E. But you always want to go in a clockwise direction. If you think about my cursor moving in a circle, it's going in a clockwise direction. So as long as you keep that in mind, GeoGebra will measure the correct angle. Otherwise, if you go counterclockwise, it gives you the reflex angle that we don't want. Okay. So maybe because it's criteria, I'm going to make this 4th angle stick out. So I got the 3 interior angles measured. So now maybe I'll make this one red. So I'm going to use this point D, vertex at C. So that's going to be just a criteria that we have to meet. So I'm going to make it red, and then I'm going to come back and make all the angles the same color, I guess. Almost done here. And then the last one. Oh, we need a point. I don't have a point over here for my 3-point way of labeling this angle here, so just grab the point tool and stick another point on there so that now we can use the angle tool and measure the angle that we wanted. Okay, so I'm going to move these measures around so that I can see them. Okay, so now what it's asking is, as long as we have this angle here, this red angle over here, as long as it's less than this angle here, right now it's larger than, so I'm just going to move my point E so that now it's less than. Okay, something like that. So that angle's less than that. There's our criteria. So now let's compare what was called angle 3 in the problem, which is 87.73 degrees, and angle 7 in the problem, which is 68.42. So angle 7 seems like it's larger than angle 3. Oh, excuse me, I have that backwards. Angle 7 is less than angle 3. And it helps students, I think, realize that, those two angles together, this red one and this green one, are a linear pair. They make 180 degrees. So as long as this angle is less than this angle here, as long as 4 is less than 8, then this angle has to be larger than this angle in here, because they both add up to 180. So angle 3 has to be larger than angle 7. So you would circle the larger than answer on that one. Now, since this angle is larger than this angle, when we're comparing the sum of the other 2 interior angles here, right, what they called 5 and 6, and then what was it, 1 and 2 on 5 and 6. Since this angle is less than this angle here, then this sum needs to make up some ground because all three have to add up to 180, right? So then this sum here should be larger than this sum of these two angles here, because the third angle inside then is larger than this one here. So using GeoGebra, you can kind of see that, notice now as it's larger than, right, we have the opposite going on here. So just being able to move things around and changing orientation around, it's really a relationship that's important here, and I think GeoGebra helps students kind of understand that relationship because of the dynamic visual nature. So anyways, I hope that made sense. Good luck.